acceptance angle and acceptance cone. Okay, now before we take up this particular task of acceptance angle and acceptance cone, first we should know based on the refractive index is what we are dealing. So to understand more about the propagation of light through an optical fiber, we deal with one of the important laws apart from your normal laws of refraction which we have studied now about the theta I less than theta C, theta I is equal to theta C based on the critical angle. We have studied all that. So they are referred to as the laws of refraction. Now here in this particular term, we deal with most important law which is Snell's law. Snell's law is given by mu is equal to sin I by sin R. So let us define this one now. The sine of angle of incidence is equal to the sine of angle of refraction. So based on your Snell's law, we give the condition as mu is equal to sin I by sin R. I is supposed to be the angle of incidence, R is called as the angle of refraction. So Snell is the name of the scientist who has given this law pertaining to when a light ray being entering from one medium to the other medium. Now here we are talking about optical fiber, so the light ray enters from denser medium to the rarer medium. So the denser medium's refractive index is more when compared to the refractive index of the rarer medium. So under this condition, we say that mu is equal to sin I by sin R. So first of all, the amount of light enters from the air medium into the core medium. So we define it in terms of that as N0. So first one is the air medium. So N1 by N0 is equal to sin I by sin R. Okay. So we write it as N1 by N0. Here mu is equal to N1 by N0. So first medium to second medium. N1 is equal to, so N1, so which implies N1 sin R is equal to N0 sin I. Or the reverse case, N1 sin R is equal to N0 sin I is equal to N1 sin R respectively. So this can be studied like this. Okay. When a light ray moves from one medium to the other medium, then it is defined as the ratio of sine of angle of incidence to the sine of angle of refractive angle of refraction. So we write this one as Snell's law. It is defined as the sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is called Snell's law. So this is how we get our job done based on this one. Next, coming back again to the acceptance angle and acceptance cone. What is acceptance angle? Here acceptance angle refers to the angle at which the amount of light ray undergoes total internal reflection. So what is that angle which is accepted by the optical fiber so that the light ray undergoes total internal reflection? So that angle is called as the acceptance angle. So let us explain it in detail about the acceptance angle. So for that we select our optical fiber. So this is your cladding and this is your core. Right? Now we are dividing it like this. Okay, this is called as the principal section of the optical fiber. Here is the reference point. Let us draw a normal over here. Okay, now you are projecting the amount of light over here. Okay, this is what we call it as the angle of incidence. This is moving from air medium of refractive index N0 to the core medium to the refractive index N1, and this is your refractive index N2. Now at this particular point, what will happen? At one certain amount of an angle, the angle undergoes refraction. So this is what we call it as the angle of refraction. So if you take it with respect to the principal axis, this is supposed to be the angle of refraction. Now this is meeting at a one particular point here. Right? Now after that the light ray is supposed to be undergoing here at this point. Okay? So light ray is moving from air medium to the core medium. So we have written it as N1 by N0 is equal to sin I by sin R. After entering into the medium, it is projected into the core material. So the light ray is supposed to be bending towards this particular point, and later on at this particular point of juncture it undergoes total internal reflection back into the fiber like this. So afterwards it is moving like this and later on like this, and so its path is supposed to be continued further and further like this, right? So this is how we take up our case regarding the acceptance angle. So let us now get into the derivative part of this acceptance angle. Regarding the definition, we say that acceptance angle is defined as the angle of incidence at the air core interface. It is defined as the angle of incidence at the air core interference, which at certain angle theta r undergoes total internal reflection, at the air core interface, which at certain angle undergoes total internal reflection, is called acceptance angle. So the light ray is to be accepted by the optical fiber so that it undergoes total internal reflection. So that is called as our acceptance angle. Now let us derive certain conditions for this acceptance angle. Now in this condition here, so the main criteria is with reference to the refractive index. So here let us take it like this. So this is your core. Okay. So this is your cladding. Now this is your principal section. This is the principal section of the optical fiber. Now the light ray is supposed to be incident over here. Okay. This we refer it as the angle of incidence, which is theta I. This is moving from refractive index N1 to refractive index N1. And this is N2. Now light ray is entering from the air medium onto the core medium. So this is core and this is cladding. This is air. Okay. Now this light ray is undergoing refraction and reaches this particular point. Let us call this point as A. Let us call this point as B. Okay. And then the light ray is supposed to be bent. So let us call this point as C and this as D respectively. Right. Now based on these respective terms, we say that angle of incidence is supposed to be incident at certain angle so that the light ray is undergoing total internal reflection. First of all, when this angle is supposed to be projected, right? So we will say that when a light ray is allowed to incident at point A into the core material of the fiber, the light ray undergoes refraction away from the normal as shown in the figure. Now we say that in terms of that, let us say here we explain it in terms of angle of incidence and angle of refraction. So first of all, theta I is what we are projecting, and this is undergoing, this is what we refer it in terms of the principal section as, say, theta R now. Okay. Now we are explaining about this theta R. So what is this theta R? Theta R is supposed to be moving away from the normal. So this is supposed to be 90 degrees. So 90, we call this as 90 minus theta. Theta R is equal to 90 minus theta. Let us take this as our equation 1. Right. Now with this we say that, so from the previous considerations what we have done, N1 by N0 is what we have taken it as sin I by sin R. So with that condition we have theta R is equal to 90 minus theta. If we frame up in terms of that value entering into the core medium, so we are entering into another medium, that is cladding medium, so N1 and N2. So in that case we say that we refer it in terms of the condition, saying that when here N1 is supposed to be greater than N2. So the light ray bends in the core medium. Okay, so we say that with respect to the laws of Snell's, we say that N2 by N1. Okay, mu is supposed to be N2 by N1. Okay, we are changing that particular medium. So with this equation, we can say that the angle of incidence and the angle of refraction, so they are with reference to the refractive index of the medium. So as we know from Snell's law, we have two medium. One is the one which is moving from air medium again back into the core medium. So here we write it as N1 by N0. Mu is equal to N1 by N0. So with that we have from Snell's law, we can attribute this one as sine of angle of incidence to the sine of angle of refraction. So sin theta I by sin theta, that is sin I by sin r. In terms of our explanation, we write it as sin theta I by sin theta r. Now you cross multiply this. So we get here N0 sin theta I is equal to N1 sin theta r. Right? So theta I means what? So for that one, what is that? When theta I is equal to theta c, the angle is supposed to be grazing through the surface. First of all, we apply the condition for sin theta I here. Sin theta I is equal to N1 by N0 sin theta r. But from equation 1, we have theta r is equal to 90 minus theta. So we have 90 minus theta. What is sin 90 minus theta? Is cos theta. So it is, we write it as cos theta. Now as we are referring it in terms of the critical angle, so it is moving away from the normal. But what should it happen? We should see that the amount is of light is supposed to be guided through the core material. So that we explain it in terms of the critical angle. So sine of angle of incidence, sine of angle of refraction in terms of your critical angle. Now here this is written as sin theta c is equal to N1 by N0 cos theta c. So why does this happen? Means we know that when angle of incidence increases, that is theta I increases, then theta r, that is angle of refraction also increases. Okay, increases. And so because of this particular condition, now what is happening? The amount of light ray is entering from air medium to the core medium. Later on it is bending and moving into the core medium. Core medium means here we can see the amount of light ray meeting even the surface of the clouding as well. Okay, so some part of the refractive index of the clouding also is an influential factor for the light ray to propagate through the core material. So we say that at the air core interface, or we can say that however at the air core interference, what is that? The maximum incidence angle is present, and that amount of maximum incidence angle is what we are making for the light ray to propagate through, is what we are calling it here as the acceptance angle. So here at that particular point, angle of incidence will be equal to the critical angle. So here we can refer that in a point saying that when the angle, however, when the angle of incidence, what is angle of incidence? Theta I, right? At say number 1, at the air core interface is maximum, that is equal to the acceptance angle, we write that angle as I max, or we can write that one as theta I max. The angle of incidence theta I at core clouding interface becomes equal to the critical angle of the Critical angle means theta c of the core with respect to the clouding. So at that particular point, what will happen? We are saying first one, 8 core interference, the amount of incidence angle is maximum. So maximum angle means what? So angle of refraction is greater. Now that refracted angle is supposed to be meeting at the core clouding interface. So that will be treated as the angle of incidence. So we are talking about this one. In the first case, when the light ray is moving from this medium, that is air medium, into the core medium, this is taken as the incidence angle, and this is the refracted angle where we are calling it as theta r. That theta r, before it gets projected and undergoes total internal reflection, it meets the surface separating the core and clouding medium. So from there onwards again it undergoes, that is it is getting reflected into the fiber material, that is the core medium. So this is treated as the angle of incidence then. So at that particular point of juncture, it is making the particular amount of light through gaze through the core clouding interface. So we call that as the critical angle. So theta I is supposed to be equal to theta c. Therefore, we are applying the condition for sin theta c is equal to n1 by n0 cos theta c. So this is the condition what we give. So this is for this condition, sin theta c being equal to n1 by n0 cos theta c. Now let us get about our equation with respect to this particular condition. So let us name this one as, say this as equation 2 and this as equation 3. Right? Next, we know that from third equation, as far as our trigonometric functions are concerned, cos theta c is written as 1 minus sin square theta or sin square theta c. Put cos theta is equal to 1 minus sin square theta. Now from our condition, we know that sin theta c is equal to n2 by n1. So this is from the laws of refraction. Sin theta c is equal to n2 by n1. We apply the condition for this one, right? So we write this one as 1 minus sin square theta c is nothing but this is n2 square by n1 square. So we can rewrite this one as root of n1 square minus n2 square by n1 square. So we can write this one as root of n1 square minus n2 square by square and root gets cancelled. So this becomes n1. So therefore cos theta c is what we are predicting it as root of n1 square minus n2 square by n1. So this is obviously what is to be substituted in equation 3. So let us substitute it in the equation 3. So where we have, so the third equation was sin theta c is equal to n1 by n0 cos theta c. So if we substitute that, we have n1 by n0 root of n1 square minus n2 square by n1. So here both the n1 and n1 gets cancelled. So the remaining factor is root of n1 square minus n2 square by n0. This is for what? Sin theta c. So let us put it under a separate case here. Sin theta c is equal to n1 minus n1 square minus n2 square under root by n0. So this can be simplified as such. Now, so here theta I is what we have referred it in terms of the angle of incidence, right? Now we know that refractive index n0, which is refractive index of air. This is refractive index of air. The value for refractive index of air is 1. So we write it as sin theta. Theta I is equal to theta c. So we can even mention that one as theta I here. So theta I, in fact, so sin theta I is maximum, nothing but the critical angle, is written as root of n1 square minus n2 square. Even adapting this equation, we have theta I max is equal to sin inverse of root of n1 square minus n2 square. So this is for the acceptance angle. Maximum acceptance angle at this in terms of n1 square minus n2 square, sine inverse of root of n1 square minus n2 square. Now here our problem is, we said that it is also referred to as the acceptance angle and acceptance cone here. So what about this acceptance cone? We have derived the equation for acceptance angle, but in order to mention that under acceptance cone we have, so here from a light source the amount of a light ray is taken as such. So this is the beam of the light ray, right? So one of the light ray is supposed to be, so let me draw it clearly. So this is the light ray what we are talking about. This amount of a beam of light ray, when it is allowed to pass through a particular aperture, then we use a converging lens to get the light ray to converge at one particular point. So we are making the amount of light ray to project onto this particular surface. So here what is that we are doing? As seen from the figure, this looks like a cone here. So this part is what I am talking about. So this is like this. This amount of light ray converges at a particular point and meets at the air core interface. This is the point what I am talking about. So this is your principal section. So as it is resembling it in terms of a core, we call it as an acceptance cone. Now in this case, we are quoting it in terms of acceptance cone. So this is called as the acceptance cone. So indeed, we can refer this point in terms of our explanation as maximum acceptance angle or acceptance cone. So we can say that acceptance angle is defined as, therefore acceptance angle is defined as the maximum angle at which the light ray undergoes total internal reflection at the light ray undergoes total internal reflection the core clouding interface. Here it is also referred to as acceptance cone half angle. Half angle means only one part of the light ray is supposed to be falling on the air core interface. So the remaining part of the light ray is supposed to be escaped and it undergoes refraction and backs into the clouding surface. So we are referring it in terms of acceptance cone half angle. So this is the part which we expect for the acceptance angle and acceptance cone half angle. So this is how we finished for the acceptance angle and acceptance cone in case of an optical fiber.